So in this video, we're going to talk about how to use properties of logarithms. So here's our chart that kind of summarizes all of the logarithm properties that we're going to talk about. It's very important to note that these properties apply only when the bases of the logarithms are the same. So we have what's called the product property. So when you're adding together two logs that have the same base, you can go ahead and multiply the two numbers together. When you're finding the difference of two logs that have the same base, you can go ahead and divide the two numbers. The power property tells us that if you're taking the log of something that's being raised to an exponent, you can bring that exponent down in front and just make that a factor. Okay, so this is going to make a little more sense when we look at some examples. So from these properties, we can derive these special properties I have listed at the bottom. We already talked about the log base b of b being equal to 1 and the log base b of 1 being equal to 0. But let's look at the log base b of 1 over x. So that's like basically the log base b of x to the negative 1. So we can use the power property to bring that down in front. And that's how we have that's equal to negative log base b of x. ln of e equals 1 because that's just another variation of this property right here when you have the base and the number being the same. The ln of 1 is 0, and that is just another variation of this property when you take the log base b of 1. So let's practice using these properties to rewrite some logs as a single expression. So here you can see we have two logs with the same base that are being added together. So I can rewrite this as the log base 2 of 8 times 3. Okay, and then 8 times 3 is 24. So this gives me the log base 2 of 24. So I used the product property to go ahead and rewrite these logarithms. So now let's try rewriting these logarithms as a single expression. So we have the same base, but they're being subtracted. So I'm going to use the quotient property. So I'm going to rewrite this as the log base 3 of 18 divided by 6. And so that gives me the log base 3. 18 divided by 6 is 2. So this becomes the log base 3 of 2. Now let's rewrite this using the properties of logarithms. So we can use the power property here. And what I'm going to do is I'm going to bring this exponent down in front as a factor. So that is going to become 2 log of 10. So this is kind of an interesting problem because notice now I have the log of 10. Remember that the log written by itself is the common log. So this is the log base 10 of 10. So I have one of those situations where the base and the number are the same. So that, remember, equals 1. So this actually will simplify even further into 2 times 1. And so that equals 2. Okay, so it's just kind of an extra step that we have in this problem. So now you can pause the video and try rewriting this as a single logarithmic expression. So here we have two logs that are being added. They have the same base because they're both a common log, so you can multiply 2 and 8 together, and this becomes the log of 16. So what happens sometimes is they'll give you numerical values. So here it gives you numerical values for the log base 4 of 3 and the log base 4 of 7. Well, what we can do is we can use that to then evaluate other logs using our properties. So for example, if we have the log base 4 of 3 over 7, well, we can use our quotient property, right? We can use that property backwards to rewrite this as the log base 4 of 3 minus the log base 4 of 7. Well, the log base 4 of 3, we know that value, that is equal to 0.0792, and then minus the log base 4 of 7, which is 1.404. Okay, so we can just go ahead and subtract those two numbers on our calculator, and when you do that, you get negative 0.612. Okay, so that's how you can rewrite it so that you can use some given values to evaluate. What about the log base 4 of 21? Well, if we think about this, remember that 21 is basically 3 times 7, right? So I can now use the product property. So I can rewrite this as the log base 4 of 3 plus the log base 4 of 7. So I can substitute in these values that I have. So this is going to be approximately equal to 0.792 plus 1.404. So when I add those two numbers together using my calculator, I get 2.196. And that is my answer. What about the log base 4 of 49? So we want to think about rewriting 49 in terms of 3 and 7, right? Because those are the two values that we have. Well, 49, remember, is 7 squared. So this is the log base 4 of 7 squared. I can now use the power property and bring this 2 down in front. So this is going to turn into 2 times the log base 4 of 7. The log base 4 of 7 is approximately equal to 1.404. So if I plug that in and then I use my calculator, I get 2 times 1.404, which is 2.808. And that is approximately equal to the log base 4 of 49. So now you can pause the video and try evaluating these logs on your own. So 5 over 8, we're going to use the quotient property. So we subtract those two values and get negative 0.263. The log base 6 of 40 we can rewrite as 5 times 8, so we can use the product property to add those two logarithm values together. The log base 6 of 64 is basically the same as the log base 6 of 8 squared, so we can bring that 2 down in front and then multiply by the log base 6 of 8. And that gives us 2.322. So let's practice rewriting this using the properties of logarithms. So here you can see we have a factor in front, so I'm going to use the power property backwards. So what I'm going to do is I'm going to bring this 2 back up here as an exponent, and so that's going to become the natural log of 30 squared. Okay, remember 30 squared is 900, so I can rewrite this as the natural log of 900. Let's try now with 3 logs. So we have the log base 3, the log of 3 plus the log of x minus the log of y. So whenever I need to rewrite something that has 2 or more logs in it, I just take them 2 at a time. That makes it a little bit easier to look at which properties to use. So for example, I'm going to do the first 2. Okay, so since I'm adding, I'm going to combine them using the product property. So I'm going to turn this into the log of 3 times x. And then I still have that minus log of y at the end. Okay, we want to do it just one step at a time. So this is going to become the log of 3x minus the log of y. Well, now I just have 2 logs, so I can go ahead and combine them using the quotient property. So when I do that, this is going to become the log of 3x divided by y. And so that is now the condensed form of this expression. So now you can pause the video and try this example on your own. You can try rewriting these as a single logarithmic expression. So what you can do is you can bring this 2 back up here as an exponent. So that's going to be the log of 10 squared, which is the log of 100. So you have the log of 100 minus the log of 4. And then we can combine them using the quotient property. So you have the log of 100 over 4, which is the log of 25. Now you can pause the video and try this other example on your own. So we're going to do one step at a time, right? So the first thing I would do is move this exponent up here using the power property. So we have the log of 3 plus the log of 64 minus the log of 6. Then you can combine the first 2 using the product property, and we get 3 times 64, which is 192. And then combine the resulting 2 logs using the quotient property, which gives you 192 over 6, which is the log of 32. So you can also use properties of logarithms to expand expressions, okay? So like the opposite of what we were doing, instead of condensing them, we're going to take a condensed expression and then expand it out. This is going to be useful later on when we're solving logarithmic equations. So for example, let's rewrite this in expanded form. Well, notice I have 2 things being multiplied together, right? Because I have x times y squared. So I'm going to use the product property backwards. So I write this as the log of x plus the log of y squared. Okay, so now since I have that exponent, I'm going to go ahead and bring that down in front. And I'm going to rewrite this as the log of x plus 2 log of y. So you can see it's just using the same properties. We're just going forwards and backwards. Now let's rewrite this in expanded form. Okay, so we have a quotient here. So we're going to rewrite this as the log base 3 of x squared minus the log base 3 of 4y to the 5th. So we have a lot going on in this problem. First here, I'm going to bring this exponent in front, and that is going to become 2 times the log base 3 of x. And then this term, I'm just going to leave it like that, the log base 3 of 4y to the 5th. I can't bring the exponent in front yet because that exponent term is not by itself, right? I also have this 4 here. But what I can do is I can expand out that product, and I can do 2 log base 3 of x minus, and then this is going to be the log base 3 of 4 plus the log base 3 of y to the 5th. Okay, so I just took this product, this 4 times y to the 5th, and I just expanded it out using the product property. Now I can use the power property to bring this 5 down in front. So I have 2 log base 3 of x minus the log base 3 of 4, and then plus 5 times the log base 3 of y. So you may be wondering why I put all of this in parentheses, but I have to do that because this is being subtracted from the 2 times the log base 3 of x, right? This whole thing is being subtracted. So when I expand it out, I have to remember that the subtraction is going to apply to both terms. Okay, so now I have this written out with my parentheses. And if I want to, I can leave it like this, or if I want to do one final step, I can go ahead and distribute that subtraction. So I have 2 times the log base 3 of x minus the log base 3 of 4, and then minus 5 times the log base 3 of y. Okay, both of those terms are being subtracted because in my original expression, I was subtracting the log base 3 of 4y to the 5th, right? Another way to think about it is both that 4 and the y to the 5th were in the denominator. Okay, so that's why both those terms have to be subtracted. Okay, so now you could try pausing the video and rewriting this logarithmic expression in expanded form on your own. So when you expand this, first we're going to use the quotient property. So you have the log base 6 of 5x cubed minus the log base 6 of y. We're going to expand out the two terms in this first product. So we have the log base 6 of 5 plus the log base 6 of x cubed. Then we're going to bring the 3 down in front using the power property, and we have the log base 6 of 5 plus 3 times the log base 6 of x, and then don't forget that log base 6 of y we have hanging out at the end. So remember that when logarithms have the same base, you can use the properties of logarithms to expand and rewrite the expressions.